Apache Flink is a powerful technology, stateful, scalable, fault-tolerant, fast, and cloud-native. But it can be a little bit tricky to implement applications and data pipelines in Flink because of all the data plumbing and glue code that you have to write. There's the connectors for Kafka and the database, wiring in an API, figuring out testing, and a lot more that you would have to do. That's where DataSQL comes in. DataSQL is a development framework for Apache Flink. It allows you to focus on your core business logic and handles the scaffolding for you. Let me show you what that looks like. We're going to build a real-time API that tracks token usage per user. It's a classic metering service where we ingest token usage events, provide real-time analytics, and alerting. It's a classic use case, but even for something this simple, the architecture is quite involved. We need an API that can accept the events. The events are written to a Kafka topic, where we buffer them before Flink can ingest and process them, compute the analytics, write it to a database from where we can query the results, and serve them back to the user on request. We also need to write to another Kafka topic when we have alerts that we want to push through the server to the user so we can alert them when their usage is too high. We can define this entire application in a simple scroll script. First, we define the table that defines the input data with the user ID and the tokens that are being consumed. We then aggregate the data by time window, where we accumulate the usage over time per hour and emit the aggregations every 10 seconds. We then define a usage alert whenever the user has consumed more than 1 million tokens per hour. And lastly, we define an endpoint where a user can query how many tokens they have consumed, again, aggregated by the hour, distincting here so that we have the most recent data per hour interval per user. Based on pure FlinkSQL syntax, as you can tell from the aggregation and the table definitions, there's a couple of elements that Squirrel adds, one being the fact that you don't have to find a table connector, in which case DataSQL will auto-wire in the connector with Kafka and a mutation endpoint. And secondly, a little bit of convenient syntax for table definitions, the ability to define subscriptions that take data streams and expose them through the API via a Kafka topic, a shorthand syntax for deduplication windows, and the ability to control the API surface area that you want to expose through hints, like in this case where we're defining a query endpoint by user ID, or in this case where we're telling the compiler to not make this table available for querying. We can run the result directly with DataSQL. This sets up the entire data stack, including Flink, Kafka, Postgres, and GraphQL API. We can now access the API and start submitting some token requests and queries with lots and lots of tokens. And then down here, this maps to the table we defined for the querying of the analytics data, and we can see how it sums up to give us this information. We can also run the subscription that we defined. So now we're waiting for results to be pushed. We need to add a couple more tokens so we can make it across the threshold of 1 million. And you can see that we get that event pushed through. Now, as we update and add more and more tokens, once the next 10-second window gets fires, we see that the data down there will update. Boom. Going back to our scroll script, let's look at how we can modularize our sources for testing or connecting to other data sources, like a use case where the token events are already on a Kafka topic that we want to consume. In DataSQL, you can import connectors externally into your script, and that maps onto the folder structure that you define for your project. So in this case, we have the API connector in an API connector folder. This is the table definition that we just looked at. And in addition, we also define a test connector that reads some data from a JSON-L file for test data. with a slightly different table definition where we extract the watermark from, or where the request time is explicitly defined, so we have reliable, predictable tests that we can execute. We can then map those data dependencies in the package.json file. Package.json is a manifest file that defines all of the configuration options for the compiler. One of the things that allows us to specify are dependencies. So we can say that the source connector maps to the text connector folder, or in this case, it maps to the API connector folder. We can then use those respective folders to map our dependencies at compile time. So if we wanted to, for instance, in the user token script, add a test case, like this one, where we are simply taking the data from this table, extracting the fields and testing the results, we can do this and execute the test case with the test command, which stands up the entire data stack, runs the tests against the processed results, and compares it against a snapshot that we have locally for the data that we are expecting. This is not only great to ensure that the script produces the right results, but we can check all of this into a repository and run it through our CI/CD pipeline, so we have confidence when we deploy that there are no regressions and the pipeline works correctly. Tests take a little while to execute, but you can see in this case, we're past our snapshot test, so everything is correct. Finally, we can run the DataSQL compile command for our API package to produce the deployment assets that we can then run in our cluster, either in Docker, Kubernetes, or in the cloud. The deployment assets are written to this folder. You can see we have the Flink compile plan here. There's the FlinkSQL that is being generated from the scripts with all of the connectors that are being templated in. There's the Postgres schema for the database tables and the query schema for the GraphQL server that exposes the data to the user. Finally, we can look at the pipeline visualization, which gives us a visual representation of the processing graph and the steps in the pipeline with all of the schema information, the SQL, and the physical plan for the respective table, as well as the sinks and endpoints that are defined by our script. That was a quick overview of DataSQL, focusing on the ability of DataSQL to eliminate a lot of the data plumbing and the glue code you would typically have to write to implement such an application. Notice that we didn't have to define all of our connectors manually, map the data between the various components, and get everything tuned and optimized. DataSQL did that for us. There's more features like the Iceberg integration, the native catalog registration that we'll look at in some future videos. DataSQL is open source, so check it out on GitHub, play around with it, let us know what you think, and best of luck.